Hello class, in this video I'm showing you how to find the p-values by using the definition. By the definition, p-value is the probability of getting a test statistic at least as extreme as the one found from the sample data, assuming the null hypothesis H0 is true. It says p-value basically describes the chance of getting a rare event. We assume a rare event does not occur in one trial. If in one trial the rare event occurs, something must have gone wrong, right? So we can say the assumption, the null is not actually true. So that's the idea of hypothesis testing using p-value. Actually, finding the value for p-value, we have to firstly determine the type of the test. First, we need to determine if the test left tail or right tail or two tails. It's important. We always start with the original claim. In this problem, number 14, the original claim is P is bigger than 0.5. Since the original claim does not have equal sign, and one of the null and the alternative has to be the same with original claim, we know the alternative is P bigger than 0.5. The null is going to be P equals 0.5. We have this covered in previous problems, I think. The null and the alternative, one of them has to be the same with the original claim, and the null has to be equal, has to have the equal sign in it. So in this case, the alternative hypothesis is the same with the original claim. The type of the test, left tail, right tail, or two tail, depends on the alternative. So once we have the alternative hypothesis, we can decide what type of test we are looking at. Since in the alternative we have P bigger than 0.5, the test is a right tail test. This is a right-tailed test, right? Right-tailed test. And the test statistic for the proportion is given. For the proportion is given is Z. Z means the Z score, right? Means the distribution that is corresponding to the score is a standard normal distribution. So Z equals 1.48 is positive, so it falls in the right tail. Is consistent. Z fall in the right tail, and this is a right-tailed test. So by the definition, p-value is the area of the region to the right of the test statistic, 1.48. 1.48. So we want to see how do we find the area? Area we know is the probability, right? We can use normal CDF. We can use normal CDF. I can show you it's 1.48. Can stop share this one and share the calculator very quick. We go to second verse. Normal CDF, we use that function. The area, the shaded region starts with, let me see what is the value. 1.48. 1.48. And there's no right bound. There's no boundary from the right, is a past infinity. Let me show you how do we find the past infinity. Second comma, double E 99. That is past infinity, the TID for calculator. Mu is 0, sigma is 1 because it's standard normal distribution. Paste. And the value is 0.069, right? If we run it. And that's the area of this region. Okay, I need to go back the notes. That's the area of the region. Is around equal to 0.069. That's the p-value. P-value is the probability of the test statistic as extreme as the, we can look at the definition here. the test statistic at least as extreme. So at least as extreme as the one found from the sample data. The value 1.48 is the one we found from the sample data. So bigger than or equal to that is at least as extreme as that one. The one is 1.48. The test statistic we found from the sample data is 1.48. So p-value is the chance of getting a test statistic at least equal to that. So assuming the null is true. Assuming null is true, we get a probability of getting a test statistic at least as extreme as 1.48. The value is 0.069. And we are going to compare this p-value with the given significance level. Significance level could assume different values. Commonly assume the value of 0.05 or 0.01, or depends on the researcher. The researcher determine the criteria for rare event, And alpha is 0.01, so that means the researcher determine 1% is a very significantly low probability. If anything happen that with the probability of 1% happen in one trial, that is rare. And since the p-value is high, remember, p-value is high, null must fly. P-value is low, null must go, right? So now p-value is high, so that means null is fly. Like null is happy because you fail to reject null. So we choose fail to reject null. Fail to reject null means you cannot support the alternative. So you have no sufficient evidence to support the alternative, which is the original claim. And for two-tailed test, question number 15 is a two-tailed test, because the original claim OC is P not equal to 0.292, right? And since the symbol is not equal, we know H1 is the same with the original claims P not equal to 0.292. Then the null would be P equals 0.292. Since the symbol in the alternative is not equal to, this is a two-tailed test. Very important. Once you know is a two-tailed test, the p-value is going to be twice of the area of the shaded region. The test statistic here is positive. It falls in the right tail, and the shaded region, the area of the shaded region to the right of 2.93 is just half of the p-value. So very, very important. If the test is two-tailed test, the p-value is going to be twice of the area of the region, to the right, the extreme side of the test statistic. And in this case, we got 0.003, and the significance value is 0.05. Since the p-value is low, no must go. So we decide to reject the no, and conclude there's sufficient evidence to support the alternative, which is the original claim. Hope the explanation helps you to understand the idea of using p-value to make a decision about the hypothesis test.